this chain rule is just to review chain rule, and I believe everybody has done it. So we're going to do it together now, using what you learned on Saturday. Okay. So first of all, let's do. Is there a problem? Okay. Let's do the normal way. If the question is a chain rule question, you apply the normal way. Do not apply shortcuts. You only apply shortcuts in question like that. I'll get there in a bit. Product rule problem. So for this, we start by saying let u be what? Speak louder.
X squared plus 8.
X squared plus 8. Once you assume u to be that, then you say, then you copy what you see in terms of u now. Y is equal to the cube root of u. Don't jump by writing the simplified version. Just write what you see first. Which, in simplified form, I can write it as, not simplified per se, but in the form that is differentiable easily. Okay? Then after we do that, right under this, my du dx will be 2x plus 0. Is it okay to write 2x? Okay? As we are beginners, so sometimes it can be confusing. So feel free to write 2x plus 0, or even 2x2 minus 1 plus 0. It's always allowed. Over time, you get used to just writing the answer directly. From here, because this is y as it in terms of u, you can only find what? dy du. And that will be 1/3 u, 1/3 minus 1, which is 1/3 u negative 2/3. You can leave that first, or you can write it in simplest form immediately. If I write it in simplest form immediately, we'll be writing 1/3 1 over u raised to power 2/3, right? Or instead of this, 1 over 3u 2/3. Does this make sense? After you have found these two in the proper form, I hope you remember this problem. I'm going to erase this. I need space. Then say, oh, by chain rule. You don't have to write by chain rule, okay? By chain rule, dy dx is actually going to be dy du times du dx. So that this looks like a fraction. Although it's not a fraction, it's not like you can separate them. Okay, just a way of remembering. Now, dy du is that. Du dx is this. So basically this is 2x divided by 3u 2/3. So I can write as 2x divided by 3 brackets x squared plus 8 to the power 2/3. You don't have to write it as square root or anything. Fractional power is allowed. And if you must, that will be cube roots, everything raised to power 2. But this is fine. Now, the shortcut. You don't have to go through all this to get it done. The shortcut is a very brief process. Shortcut. Or maybe we do the other one, then we do the shortcut together. The second one, give me the function again. 1 minute. Yes, Karen?
X squared plus 5x plus 7.
X squared plus
5x plus 7 to the power 4 over 2.
Okay, so here, let u be x squared plus 5x plus 7, then y will be what? U to the power 4 over 2. Which immediately, Callista is busy doing her thing while we are doing our thing. Which immediately can be written as that. The reason is I want to have k and x to the power something in that format. Okay? From here, du dx will be 2x, 5 times 1, 0, which is 2x plus 5, a binomial. From here, dy du will be 1 over 2, 4u to the power 3, right? Which is 2u cubed. Okay? So, dy by dx, always write the chain rule. Even if you don't write by chain rule, always write that expression. dy du times du dx. dy du is 2u cubed. Because this is binomial, it has to be in brackets. So the result will be 2x squared, 5x plus 7, and 2, this is to power 3, 2x plus 5. Okay? Now, let's do the shortcut. To do shortcut is to write your dy dx directly from y equals cube root of x squared plus 8. The first thing you do to do the shortcut is to write it as a fractional power. That will be x squared plus 8 to the power what? 1/3, right? The next thing is just to say dy dx. Now listen. The first thing you need to do is pretend this is covered and it is one variable x. Again, pretend everything here is one variable x, which is actually doing this because what you did was to assume it is one variable, to have it like this. So pretend it is one variable, now differentiate the way you see it. So it's going to be 1/3 of that variable raised to power 1/3 minus 1. Then you multiply by the derivative of that variable. Do you understand? Then you differentiate the brackets, basically. Differentiating the bracket is 2x plus 0. Am I making sense? So just copy and paste your variable. And the rest is simplified. That's the shortcut. Am I making sense? So because this is going to be 1/3 x squared plus 8 negative 2/3 2x. So this will be numerator, this will go down and join 3. Right? So that will be, I write denominator first, 3 x squared plus 8 raised to power 2/3, and at the top I have 2x. And that's exactly what we got here. If you do this by shortcuts, it's the same way. From y equals x squared plus 5x plus 7 to power 4 over 2. I could just write it as 1/2 x squared 5x plus 7 to power 4. Okay? So this is one variable, p, for example. So that's like half p to power 4. Understand? So next thing is dy by dx. Yes, together now. Tell me what to write. Half times 4 bracket, right? Raised to power 3. Then immediately you multiply by derivative of that bracket, which is 2x plus 5 plus 0, right? You don't have to put the plus 0. And you copy this back. And that gives you, this cancels immediately. So that's 2x squared, 5x plus 7 cubed, 2x plus 5. This shortcut shouldn't be used if the question is a chain rule question. If the question you can see is a composite of two functions. Okay? But if it is, you have a product rule problem, of course you use it. Because we do not expect you to differentiate u using chain rule, differentiate v using chain rule, and apply them in the product rule formula. That is when you can use the shortcut. So this is how we apply to a product rule formula. Now, we've introduced this on Saturday. I believe those that were not present watched the video. Did you? Crystal? Oh, Crystal was there. That's the last. Lillian. Lillian must have done this in IGCSE too anyway, right? Okay. So, the first thing, we use product rule as the name implies, product rule. When the function to be differentiated is actually a product of two different functions. And we have seen using some experiments that we did, that tabular experiment, that it is not the product of the individual derivatives. Okay? It is actually one function, one of the products. No, the product is everything. I think one of them, each of them is called multiplant or something. Anyway, one of the functions to be multiplied, you pick them one after the other. If you pick A, you multiply by derivative of B. Then you let them change position. But like I told you on Zoom, I will encourage you to start with a V. Even though it's immaterial which one you start with. The reason is simple. In quotient rule, V is always the first one. So while learning to make it easier for me, I follow this so that I'm used to that consistency of V coming first. Is that making sense? Alright, so the first thing is to identify your U and V in that order, UV, just like that. So from here, U is equal to x plus 1, 4, or you can say let U be that, even though that's what everybody uses worldwide. So V is equal to 2x minus 3 to the power 5. You see, the U this time around is not like the U in the chain rule, where where U is representing that function in the bracket alone. The U is everything. Because function Y is a product of U and V, which are each of them functions of X. So including the power with the rule, that's your U and V. Understand? So by product rule, you need to differentiate them one after the other. Du dx, you work out that. dv dx, you work out that. And you see, this is like a chain rule problem on its own. So we're not going to say, oh, let this be U, so that your U is equal to U raised to the power 4, like it doesn't make sense. That's why the shortcut is allowed here. Okay, so let's do it together. Yes, du dx is what? 4 x plus 1 raised to the power 3. Then times what?
X plus 1. Wait, 1.
1, which is the derivative of the bracket. Okay? In this case, yes, dv dx 5 raised to the power 4. Then times what? 2. If it is negative, you have to use a bracket. Okay? So you write it properly now. 4 x plus 1 cube. And this is 10, 2x minus 3 to the power 4. Any questions? Then you say by product rule. Of course, you don't have to write that. By product rule, always state the product rule. You know, the more you state something, the more it sticks. You don't have to look at any formula booklet anymore. Okay? So I will encourage you to always state it. So it means my dy by dx will be, yes, so it's like cross multiply. V and du, U and dv, like that. Okay, but I like to start with V like I said. So that will be 2x minus 3 to the power 5, 4x plus 1. If this 4 was negative, it has to be in bracket, plus U, x plus 1 to the power 4, 10, 2x minus 3 to the power 4. This is why we teach you factorization. I must have told you in Form 3, because I thought most of you here. Is it most? Okay, 9. How many out of 9? Raise your hand if you're in my Form 3 class then. 1, 2, 3, 4, 5. Okay, so it's still most. Sorry, Karen. Sorry, Nakita. Where were you in your Form 3? What school? You're here already?
Yeah, the first year.
So they put you in standard class? You didn't tell them how smart you are? Well, was that your first year?
Yeah.
Oh, that's why. They always put them in standard class first. Should have told them, I'm smarter than this man. I want to go. I want to go and say, Mr. Daniel will be my teacher in 2 years' time. Let me go now. Well, we can't see the future, unfortunately. Anyway, so this is why when I was teaching that class then, I said some of these factorization are important in calculus. But not many people will understand what I meant. Of course, I didn't expect them to understand. So this is a group. This is also a group. You look at each of them and see what can be factorized. Clearly, 2x minus 3 is common. But to what power is the next question. So I can see 2x minus 3. But to what power do we factorize? 4. Can you see that? Also, x plus 1 is common. To what power? 3. So from the first group, what do I have left? I have 4. You take the monomial first. It's easy like that. I have 4 followed by 1, 2x minus 3. This is all gone. On the second group, I have 10, x plus 1, and all this has been brought out. Once you simplify this, that's your derivative. So this is simply 2x minus 3 to the power 4, x plus 1 to the power 3, 8x, right? Minus 12 plus 10x plus 10, yes? And finally, all right, 2x minus 3 to the power 4, x plus 1 to the power 3, and this will be 18x, right?
Yes.
Minus 2. You can take 2 out if you want. It's just to write it as simple as possible. Don't expand, please. No one is asking you to do unnecessary work. Just factorize and put it. So the reason why this factorization is also important is in quotient rule, it's possible one of these is a denominator. So you can simplify. That's why we encourage this factorization. Understand? This is all about product rule. The rest is just practice. Okay? Let's begin. You have your paper, right? So, can I see the paper on the product rule?
我成的教室。这种情况下，应该先写这个，因为应该 bracket 是有一些所谓的。
Oopsie. It's okay. Just kidding. Maybe I put something similar to the practice first, because then after you do 1 or 2 practice, then you can focus on this on your own. Is that okay? All right. You all right, miss? Just feel like being lazy today? It's allowed. Sleepy? What? You didn't get enough sleep? Calista? I think she didn't get enough sleep. So, try the few that I'm going to write on the board, please. Question 2 is not. Just continue with question 1. What's that question 1 again? No. You didn't write already?
Yeah, the one.
No one has written anything. Have you written the question 1 I put here?
Yeah.
What is it?
5x squared
Okay.
multiplied by bracket 3x squared minus 1.
3x squared minus 1 raised to the power 2.
2.
2. Okay, that's what I want. Thanks. Towards the end, I'll only introduce quotient rule. Just like we did today, we'll do it next time. Introducing it, we allow anyone who wants to practice ahead to at least have more information. Please make sure you use product rule, even though you can expand and simplify. Use product rule. The idea is to get used to product rule. If any of these questions on the board is in your worksheet, you're free to work it in your worksheet. So you don't have to work it twice. I'm not sure what I put in the worksheet.
you get this?
Yeah. Remember when we used to do this?
Oh, you expand.
So that's how we come up with it. Oh, I know what you did. I know what you did. You forgot to put the negative sign.
Oh, you s-
Oh.
He was like, ah, it's a sign. Okay, what's the water?
This is one period, right?
Not hard theories. The plus and minus.
Tomorrow, no, we don't have math.
The plus and minus.
Why do I get sick?
Today is Tuesday,
The values.
Come back tomorrow.
it's a Thursday. Let me see. So we can actually do more practice. Thursday single period. Okay.
Yes.
So we'll use that to do more practice. And maybe towards the end I can do something. Because we really need practice.